Alright, so to discuss our new topic today, so we're going to have freefall. So upon learning the motion along the horizontal axis, or horizontal motion, or kinematics along the x-axis, however you want to call it, we're dealing with, so if this is your Cartesian plane, let's say, okay, so we're dealing with this motion, the motion that happens here. So this is what we did from the previous topic that we had. So now what we want to focus on is the movement on the y-axis, which is the movement of free falling bodies, or what we term, or what we call this lesson, which is free fall. So the technique that I want to teach you is, by the way, before that technique, I just want to give you a very short, a very simple concept regarding this topic. So G, which is acceleration due to gravity, right? So this is what will replace A from the previous equations that you had. So we'll replace A. Alright, the reason behind that is because if you're going to notice, all of the things that we throw up in the air return to the ground, diba? So from the years of understanding this concept up to arriving on the famous experiment of Galileo on the Leaning Tower of Pisa, we have now understood that falling objects move at a constant rate, which is 9.8 or 9.80 meter per second squared. So that means every second the velocity of a falling object increases by 9.8 meter per second, right? Though, so you might want to recall the definition of acceleration. So, diba? So acceleration is velocity per unit of time, or meter per second per second. So that means if you're accelerating, or if you're speeding up, that means you're accelerating, you're increasing your velocity over time, right? So let's say your v sub 0 is, let's say, 0 meters per second. Then after 1 second, so that would be v sub 1, that would be 9.8 meters per second. Then at v sub 2, what would be your velocity if you're traveling at this constant acceleration? That would be 19.60 meters per second, correct? Then by v3, or your velocity after 3 seconds, it will increase again by 9.8. So that, what would that be? 29.40, correct? So something like that. Okay, so for the technique, so you have 4 kinematic equations, right? Aside from the usual acceleration is velocity over time, and velocity is distance over time. So we have this equation. So let's have a recall on those. Okay, let me erase this as well. So okay, so let's recall those. So we have v, or the final velocity, is equal to initial velocity plus acceleration times time. Then we have delta x, correct, is equal to v plus v sub o over 2 times time. Then we have delta x again, or the displacement is a delta t squared over 2 plus v sub 0 delta t, correct? Then for the fourth equation, we have b squared is equal to b sub 0 squared plus 2a delta x. Okay, or if you prefer the other form, you can remove the square here and place a square root here. Either works. Okay, so this is for the x-axis or the horizontal motion. How about for y-axis or the free falling bodies? Okay, so for the first equation, so if we're dealing with it independently, okay, so this form would be almost the same, okay, but always remember that you're going to replace a with g so that we can distinguish that this equation is used for vertical motion. Okay, so if you're going to notice, so this is for the first one. If you're going to notice for the second one, so this doesn't have a on it. So that simplifies your the equations that you have to remember, because this doesn't exist here. Okay, so you will never ever going to use this on free falling bodies, okay, or objects moving on the y-axis. Okay, so for this one, so you're going to have, instead of delta x, of course, so if you remember my explanation earlier, all right, so we're dealing with this motion, okay, not with this motion, okay, not that one, not that one, this one. Okay, so you're going to replace all the x's with y's. Okay, other teachers use h, so that's fine as well, whatever your fancy is. Okay, I prefer y because it deals with the axis, and you will always remember it, especially on the next topic that we're going to have. Anyway, so going back, so this is g delta t squared over 2 plus v sub 0 delta t. Alright, then for the last one, this would be b squared is equal to v sub 0 squared plus 2g delta y. There you go. So to further understand how we're going to utilize it, we're going to have some sample problems, but I have this very useful tip aside from this one. Okay, so tip number 1, always, okay, always, wait, let's write it in capital letters, always. All right, always, okay, always remember that g is downwards. Okay, always remember that. Okay, so what's the consequence of that? What's the consequence of that? So speeding object or object gaining velocity moves downward as well. Okay, so what this means, this second what do you call this statement? Okay, so if you're going to remember this first one, all right, so all objects will return to the earth or to the ground. So that's the purpose of this equation. So remembering that, if you're going to translate it on the equation, it means objects that are speeding off moves towards the earth. Okay, so what I want you to remember is, if this is true, then that would mean that g wait, so where should I write it? Sige, dito na lang. Okay, remembering this one, that would mean g is positive kapag it moves downward. Okay, let's just write it instead. So don't forget that. Okay, so I mean, it makes sense. If you throw something up, it's not going to fly towards the outer space, right? No, it will stop at a certain height, then it will return to the earth. So that means G is applying a negative value, or G is slowing the motion of object that is going up, right? So that means if you're going to put it into an equation, what do you call this? G should be negative when it's moving up. But once your object is returning towards the earth, because you're going to always remember that G is directed towards the ground, G should always be positive when the motion is towards the earth. Okay, so to further understand it, let's have some guided practice problems to understand the uses and the different scenarios where we can utilize these equations.